Hi, my name is Shafi,
And I'm Lucas,
and we, along with Kumar and Shawal, are the qualified
qualified
pairs.
pair, and excited to share our design process and proposal for this competition.
Design concept and site optimization towards climate responsive design.
We began this project by taking notes of our site observations such as possible linkways, activities, site connectivity, and the surroundings. No worries, all this was done before the circuit breaker.
A detailed climate analysis based on the sun path and prevailing winds of Singapore, along with our site observations, led to our vision of creating this physical, visual, and eco link between buzzing commercial orchard and quiet Grange Road residential.
Our passive design strategy starts with creating a cooler microclimate within the site.
The first strategy is increasing site ventilation. We realized that the northeast and southeast directions were not obstructed by many buildings and utilized this to our advantage. The wind flow strategy is developed based on the fish gill concept, replicating the flow of water, also a fluid, through its mouth and gills. The retail blocks create the mouth opening while the residential became the gills or the wing walls to divert the wind flow. CFD simulations have helped us refine and assure that this concept works. The second strategy was to reduce the urban heat island effect. Extensive landscaping by creating a terrace valley at the center of the building, along with the biosphere replicating a river within the valley, helps reduce heat through evaporative cooling. Green roofs, sky terrace, overshadowing, and cool panes help further.
The optimized massing thus has wing commercial podium and residential towers. Sandwiched between them is a transfer level to transfer structural loads and house service areas. Level 6 is the residential link and recreational level with a swimming pool, the valley at the center of the commercial, the visual pedestrians and green link. A unique canopy roof has been designed close to the proposed future MRT.
Next, we will be focusing on sustainability strategies, which include four key components established through an integrated design process.
In order to prioritize technologies and strategies to cut energy consumption, a number of strategies has been identified within four broad areas: passive, active, smart management, and energy harvest.
Passive strategies are a fundamental prerequisite in the design of energy-efficient buildings. Designing commercial and residential layouts such that 90% of the common areas are naturally ventilated is a primary strategy. Under active design, a shared optimized water-cooled chiller similar to a district cooling system for the entire development has been proposed. Smart energy management through green lease, performance, contracting and energy harvesting from not only renewables but hot water recovery helps achieve a super low consumption.
We use super low energy building website to compute energy consumption and identify new technologies, compute the EUI and various parameters, while comparing other similar mixed-use buildings. Close to 50% reduction from a standard building was realistically achievable.
The design integrates various levels of landscaping along with a waterscape in response to the site context to enhance biodiversity and provide visual relief. PUB-ABC features have been explored. In particular, a biosphere has been proposed in the midst of a commercial atrium valley to treat stormwater runoff.
User well-being has been addressed, including ultraviolet germicidal irradiation system within the ACMV system to air for air purification, a possible countermeasure against the COVID-19 pandemic. Moving towards zero waste, Singapore food recycling and waste segregation has also been integrated to close the waste loop within the development.
We will be talking about design for manufacturing and assembly, DFMA, for residential and commercial blocks.
Taking a look at the top two concepts that Singapore is currently applying, we chose to use a hybrid system along with mass engineered timber for the commercial and PPVC for residential.
How were the modules developed? We started a Bible diagram to understand the relation between spaces. It was noted that most functions are quite common for all unit typologies, only that bedrooms kept adding on. Therefore, grouping spaces close to each other helped develop the concept of PPVC modules.
Further refinement led to 4 typical PPVC modules which could be reorganized in multiple ways. Each PPVC unit was designed not more than 3 meters in width and 6 meters in length, considering transportation requirements.
For instance, looking into a typical 3-room flat Unit B, the modules are comfortably rearranged to form a well-designed layout.
Exploring further combinations leads to design possibilities for 2, 4, and 5 rooms layout, namely units A, C, and D, to match the design brief.
The typical floor configuration was achieved based on the competition requirement for the different percentage of units. A central spine of natural ventilated common corridor space along with green decks has been designed to create a social community.
As mentioned previously, a hybrid design with concrete and cross-laminated timber, or CLT, has been proposed for the commercial. CLT has been proposed for the flooring, interior walls, entrance canopy, decks, as well as shading device for the residential. And how does the PVVC for its commercial and residential come together? A structural transfer level has been proposed at level 5, taking inspiration from projects such as the Scotts Tower and the OCBC Centre.
Digital technology has been the backbone of our design development, and to us, the most exciting part of the presentation. As seen, the focus of integrating technology has been towards the design stage, starting from performance analysis and optimization, dynamo scripting for parametric design, conflict resolution and automation of repetitive elements.
The highly optimized design responds to the site context, wind flow, energy consumption, and passive strategies has only been possible through repetitive software simulations to analyze performance of various strategies.
The concept of parametric design has been explored to create an interesting responsive shading device design for the residential and commercial blocks. This has been achieved by programming dynamo scripts along with Autodesk Revit.
The objective of the program is to achieve an angle earning 50% shading coefficient for the southwest and northwest facing shading devices. PCA RETV code has been used to create reference input for the angle based on the projection depth and the width of the window. For residential, cross-laminated timber roofs, floor to ceiling panels are created as family units angled based on the programming output to reduce solar heat gain while providing panoramic views of the city district. A simulated solar analysis affirms the target heat reduction.
For the commercial podium, perforated aluminium facade panels are instead proposed to create a contrast. The perforations also give a variety of lighting patterns depending on the angle of sunlight and also allows for natural ventilation at the peripheral circulation corridors.
Dynamo has also helped us work on our presentation by helping to place 3D room text and generate sheet lists. Using programming as a powerful tool has also helped create interesting beam layout for the entrance canopy with minimal effort.
Digital tools such as Navisworks help us as a team to achieve holistic integrated building system through collaboration and coordination. For instance, clash detection enables effective identification and reporting of interference among various of our roles and disciplines.
A short video shall now be presented to summarize our design process and team effort.
conclude, our design proposal integrates architectural concepts and engineering ideas using digital technology to explore, optimize, and visualize strategies to create a healthy, vibrant interface for users and a positive environmental impact. Thank you.
Thank you.